All right, so before we were multiplying, but we were multiplying the whole previous function by a number. This time we're going to multiply just the x. That's going to give us a horizontal effect, and that's going to make it horizontal stretching and compressing. Again, it's going to matter whether that number is bigger than 1 or between 0 and 1. So, if we multiply the x inside by a constant that's bigger than 1, we're going to compress the graph of f of x horizontally towards the y-axis this time. If it's between 0 and 1, and we multiply the x, it's going to stretch it away from the y-axis. Okay, so imagine we start with the same basic function, something that looks like this. All right, so this is what we're considering our f of x. That's what we're starting with. And if we multiply the x by a number that's bigger than 1, then this is going to compress it towards the y-axis. So what's going to happen is, instead of taking a while to get to that hump there, it's going to happen sooner. It's still going to get to that hump, but it's going to happen faster. So this is f of cx with c greater than 1, and a similar thing on the other side. Okay, so that, as you can see, is compressing the whole function towards the y-axis. Now, if it were a number between 0 and 1, that's going to stretch this away from the y-axis. So it's going to stretch it out like this. It's still going to reach the same high point, but it's going to go a lot further. And similar, hold on, let me fix that. Similar on the other side. Okay, so that's what happens when we multiply the x. We either get it squished towards the y-axis or stretched out away from it. All right, again, it's going to be nice to be able to use some points to tell us what's actually happening, even though we may know, but to actually help us see what's happening. All right, let's take the square root of 2x. Basic function it's coming from is the square root of x, so we need that. Okay, so now I want to think about what's going to happen when I multiply the x by 2. So I'm multiplying the x directly, so that means it's going to be a horizontal effect. And what is the difference of doing it by a number that's bigger than 1 than smaller than 1? Well, if we're not sure, we can see. All right, so let's take the value 1. If I plug 1 into the square root of x, our original function, the square root of 1 is 1, so I would get that point. Now, if I think about this new function, the square root of 2x, if I plug 1 into that, I would get the square root of 2, which is like 1.4-ish, but it's bigger than 1. So it would be up there. That's telling me that everything got squished towards the y-axis, and instead my function now looks like this. All right, because it got squished this way. All right, so that makes sense. This one is now the square root of 2x. Now what if we did the square root of x over 2, which realize is the same thing as thinking about square root of 1/2 x? Well, it's still coming off the basic function of square root of x, so I'd start with that. Okay, so let's start with that, and if I were to put in, say, the value, let's pick an easier one to work, so we can pick any point. So I'll pick one that has nice values. Let me pick 4. If I put 4 into the square root of x, that's going to give me 2, right? Square root of 4 is 2. So now if I go back and I do this, if I put 4 into there, the 1/2 times 4 is 2, so I get the square root of 2, which we said was a little more than 1, so I would be here. So now I've seen what happened is my function got spread out. So I got moved away. So think about this thing getting pulled to this original square root of x getting pulled to the right, and it gets stretched out horizontally. Okay, so those are our horizontal compression and stretching. The final transformation that we have is probably the simplest one to envision. These are reflections. So basically now we're going to put the negative in. All right? So if we put the negative in and multiply the whole previous function by a negative, what that's going to do, I did the whole function, so it has to do something vertically. So that's going to flip this up and down. Flip it over the x-axis. So if I had something that started out like this, imagine this is my original f of x. All right, if I had that and I put a negative on the whole thing, all that's going to do is flip the whole thing over the x-axis, and that would be negative f of x. So applying a negative to the whole previous function just flips it over the x-axis. Whereas if I apply the negative directly to the x inside, that's going to flip it over the y-axis. So if I had something that looked, say, like this originally, then this is just going to get flipped this way now, and it's going to look something like this. So that is f of negative x. Okay, so those are the two reflections. Let's see some examples. All right, g of x is negative x cubed. Okay, so this is negative to the original x cubed. All right, so we took the original function x cubed, multiplied by a negative. That means it should be a vertical effect. So let me take the original x cubed, which looks something like this, and now I'm going to flip it vertically. All right, so anything that was above the x-axis goes below with the same shape, and anything below goes now above, and there's negative x cubed. Whereas here, I have the square root of negative x. So now the negative is inside. I'm still starting with the square root of x, but then I'm going to put a negative on the x. That should be a horizontal effect. So if I started with the square root of x, and I flipped it, so I flipped it horizontally, there's the square root of negative x. Now, actually, there's an interesting note on the first one here, in that what we did here in flipping it vertically ends up looking just like what would happen if we flipped it horizontally. That actually makes sense, because think of this. Negative x cubed turns out to be the same thing as negative x all cubed, because this ends up being negative x cubed. So in this case, doing it as a vertical and doing it as a horizontal ends up being the same thing. That doesn't happen all the time, certainly. So this just happens to be a case where that's happening. So the next thing we're going to do is going to see how to put all these together.